Okay, we're going to dive into standard form of a parabola. So yesterday we talked about it like this. Can you also maybe write that beside there? Okay, so yesterday when we were talking about it, what did the number in the brackets do? It moves it left or right. And what could we say? It did the same as our brain wanted to do, or the opposite? It did opposite. And then the number at the end did an up or down. And it did in the same way, right? So if it was like a plus 5, it went up 5. But here, if inside the bracket there was a plus 5, it actually went left 5. What's the difference between what we did yesterday and how I put this one today? What's the only difference you could see from here to here? The K. What happened to the K? The K moved. So in this one, I just moved the K, so it's going to be very much the same concepts, it's just that the K is on the other side. If I move the K to the other side, it's going to change it to an opposite sign. Okay? So the vertex is going to be always the H and the K, because the H is always telling us left, right, and the K number is always going to be telling us up, down. Do you notice in these formulas, so you will get these formulas from me, do you notice how I did a minus sign and a plus sign? If you see a subtract sign in a formula, it's always going to be saying do something opposite. If you see a plus sign, it's going to say do the same thing. So here, what am I doing? Opposite and opposite. And the slope is going to be your A value. So what are the things that this A value can tell me? So do you remember this number in the front? What kinds of things could it tell me about the parabola? If it's flipped or not. So if A is positive, you would open upward. But if A was negative, you would flip. So A tells me about if I'm a U or flipping U, and if it's all about positive or negative values. And then do you remember, we just did this example. If A was 5, and you told me it narrowed it, so it's going to tell me about these arms. So where should I kind of place these arms? So if A is bigger than 1, it got narrowed. And if A was less than 1, it went wider arms. And the vertex is going to tell us where to start. That vertex is always the most important thing, and it's going to be the starter to everything. We're going to base our symmetry around it. Okay, so here we go. Example 1. What is the coordinate of the vertex? So the first thing is the x value comes from the bracket number. So should I be the same as that number or opposite? I need to be opposite. Okay, because the formula tells me it looks like this, so opposite. And so the number that's separated, this is the k value. So should I go with a -2 or a +2? Positive. They're both opposite. Okay, because I'm looking at this one, they're both opposite. Okay, so in this formula, it's opposite, opposite. But if it's on this side, it is opposite, same. So do you see the difference in that K movement? Okay, what is the slope? So what is the multiplier in front of the x part? If you were to multiply this out, how many x's would you have? What's the number in front of the x part? 1. There isn't anything placed there specifically, so if there's nothing there, what are you multiplying by? 1. Okay, we're going to graph this. You ready? So go -3, 2. So left 3, up 2, and draw a point. Okay, yesterday we talked about the pattern. If you were to move over 1, okay, what's the relationship going to be on the up? 1. If you were to move over 2, 4, because you remember the relationship right now is a squared relationship, x squared. And then 3 over should be 9 up. Okay, so here we go. On this point, can you move over 1, up 1, over 1, up 1? Okay, this is important. You always have to reset. So we're going to go back to the start, back to the vertex. Okay, go over 2 and up 4. And then the next set is just a little bit off the grid, right? The height of that would be exactly what number would you get to as a height? Anybody know the number of height? 11, yep. Because this height had 2, and then we went up 9, right? So we're at 11. Okay, when I draw it, should I be curvy or should I be pointy V? Curvy. And what should I put at the ends? What's important? Arrows, because it will keep going. All right. Domain. So do you remember domain word said what's going on with x? So when we talk about x, we have to discuss it as left to right. Has to be that way. So what's the left we're going? What's this doing left? -infinity. To what's this doing to the right? +infinity. Does that make sense? The word range tells us about y values. So low to high has to be that order. So what's the lowest height of this? 2. Is it exactly 2? Yes. So square bracket. To the highest forever, right? We go up. Okay, the axis of symmetry is the cutting line, and I would cut it right exactly there. Okay, so that is a line. To graph a line, you need to make an equation. So we're going to make an equation because that's a line. What is always the same on this line? Anywhere I'm on this line, what's going on? It has the same what every time? It has the same x value. And what is that x value? -3. And you know where that's going to come from? It's always going to be this value, wherever your x is here. Okay? This part, 25% of you are going to forget that on the test. That always happens. You can't just write me -3. That doesn't even make a line, okay? So make sure it's x equals. Okay, and then we did this yesterday. What does a y-intercept mean? A y-intercept is where x is 0. So that's what I did. I went into the equation and I made x 0. Remember we did this yesterday? Okay, so math-wise, brackets. 0 plus 3 is 3. Exponents squared is 9. And then I'm going to have to add 2. And I get 11. What do you think? Does that match our graph? Does it cross the y-axis at 11? Yep. I almost always get somebody on a test or an exam who has their math and their graph and they're just not matching. Okay, they should always match, right? Okay, here we go. Vertex. So I need to take the bracket number. So what kind of 4 do I want? Think about opposites or sames on the 4. Opposite. And the k value, so just the number that's detached, so that's the 1 part. Is it a plus or minus 1? Did you write -1? Opposite. And the slope, so what's the multiplier number in front of the x part? -2. Okay, so I need you to plot the vertex. So there's my 4, -1 vertex. Okay, the chart 1, 1, 2, 4, 3, 9, we already ran that chart, is going to be different because we have a slope. Okay, so this slope is going to change things, right? Because it's going to make our shape go down. It's going to be narrowing our arms. Okay, so what we're going to do is we're going to times this pattern by -2. So -2, -8, -18. Okay, so pen on the vertex. Can you move over 1, down 2? Over 1, down 2. Okay, and I did it on both sides. It's always going to happen both. Reset. Can you move over 2 and then down 8? So with this slope of -2, my shape should be flipped and it should be a little bit narrower than normal. Do you see those things on your graph? Okay, domain. This one should start to get easy. What's always the domain? Left and right? -infinity to infinity. Range. A little bit different than last time because it's flipped, so it's going to change here. The lowest, so we're going down. So -infinity up to a top height of -1. That's the highest height we go. So do you see how from last time, right? Here we had the number on the bottom, but here we have the number on the top. Axis of symmetry. So if I could cut it, it would be on a line. I'd make a cut line. So I need an equation. And how do we start this equation out always? X equals, and then the x value it's going to go through is 4. Okay, y-intercept, so we're going to make x 0. That's always the idea. Okay, bed mass. Brackets. -4. What is -4 squared? Positive 16. So there's something that tricks people because they also, do you understand if you were to do this in your calculator? It's not doing what you want it to do. Okay, that's going to be wrong. How would I fix the calculator maneuver if I wanted to do it in my calculator? Brackets. I would be like this. This is the number I want. Okay? Times -32 minus 1. Does that seem appropriate? Does our graph look like it would cross way down there? Yeah. It'll be low, right? All right, we got 2 more to plug through. Oh, actually, sorry, don't flip yet. You might run into these words. On this example, the vertex is on the bottom, so they refer to it as a minimum. Does that make sense? Because it's the lowest. And on the other example, this vertex ended up on the top, so what do you think it's going to be called? Maximum. Okay, so the vertex can either be known as a minimum or a maximum because it'll always end up either on the very bottom or on the very top. So you're going to see those words somewhere, and that's why. Okay, next one. I just rewrote it because it's on my staple on my page. Okay, vertex. What's the number in the bracket? We got a 5. So what kind of 5 do we want? Do we want a positive or -5? -5. Okay, and where's the K number? Where's the number by itself? Does anybody find one? There isn't one, right? So what should I write? 0. There's no number there. There's no K value at all. So we can write 0. What's the slope? -1, because that's the multiplier. Okay, so we're going to graph. So give me that vertex. Give me 1, 1, 2, 4, 3, 9 on the chart. Should we leave the basic chart? This is basic, or should we change our chart? Did we have any slopes that changed this pattern? Yes. This is going to change things. So you always have to multiply the chart. So -1, -4, -9. We're changing that chart by negative. So can you start on the vertex, head over 1 and down 1? Are you always resetting yourself? Go back to the vertex every time. Okay, reset, 2 over, 4 down. Okay, that A value was negative, so I should see a flipped parabola. When it flips, does it create a min or a max? Max. Okay, domain, you got that one already? Shouldn't have to think again, it's the same every time. Range, so we got to think low. So the low, -infinity, to the highest height of 0. Where does that number always come from? The y part, because the y is always height. Axis of symmetry, if you could magically cut it in half, what does it always start with? X equals -5 is always the number we're going through, the vertex number. Okay, the y-intercept is me always making x 0. That's always the idea. What are you getting out of this value? 5 squared is 25, but then I have to do what? Times. Does that number make sense? Are you looking at your graph? Would it do that? Yeah. All right, last one. Okay, vertex, so the bracket number. What are we going to do? Same or opposite? Opposite, so -1. Bracket number. K number. Is there a number that's floating around alone? Yes. Okay, should I do the same or the opposite? This time you're going to do the same, remembering that it was this one this time. Okay, the slope, so what's the multiplier in front of an x? 3. Okay, this time I'm going to make you do the criteria before drawing it, to see if you can recognize stuff without the drawing. What do we answer for domain? -infinity to infinity. Range. Before I ask you range, can you tell me if this parabola is opening up or flipped down? It is opening up. How did you know that? Because your slope was positive 3, right? So it's going to open up. So now, what is my range? So what's the lowest height on this thing? The lowest height is, where am I going to grab height from? The y value is my height part, right? -3 to infinity. Axis of symmetry. We always do x equals to make a straight up-down line. What x value are you going to go through? -1. And then the y-intercept, okay, so math, I'm going to go 1 squared is just 1 times 3 so I'm getting 0. Okay, so let's graph and see if we match everything. Can you give me your vertex on your drawing? So -1, -3. Okay, pattern 1, 1, 2, 4, 3, 9. Always start there. Always, always, always. Then we adjust our pattern. So we said our slope is 3. So we're going to times by 3. So we're going to be heading 1 over and then 3 up. Reset 2 over and 12 up. So instead of maybe literally counting 12 ticks, understand that you're going from a -3 plus 12, so 9. So you should be at the 9 value, right? Is your shape looking really skinny? Because it really narrows out, right? That bigger the number. So if you make this number bigger and bigger, you're going to get narrower and narrower. Okay, so you should ask yourself this when you're doing your homework, because you're probably not drawing every one. You should say, what's my slope? If my slope is positive, I'm going to be opening like that, which means I'm going to have a minimum. And then also, how do we change that? If your slope is negative, think about how you will look, which means you're now going to have a maximum. Okay? And I think on your homework today, like for instance here, if I'm asking you that question, I would have said min of -3. I think I might have like written in that value. So this is a minimum of -3. So this one I would have said has a maximum of 0. Okay, so just using those words.